Chemistry Higher Unit 1, Energy Matters. In this unit you'll hear about reaction rates, enthalpy, catalysts, patterns in the periodic table, bonding and structure, intermolecular forces of attraction, properties of elements and compounds, and the mole. It also covers the prescribed practical activities for Unit 1. Unit 1, Energy Matters. Reaction rates. The course of a chemical reaction can be followed by measuring changes in concentration, mass and volume of reactant and products. The average rate of a reaction can be calculated from initial and final quantities of reactants or products, and the time interval, i.e. average rate, is equal to change in concentration divided by time taken. The rate of a reaction is proportional to the reciprocal of time taken, i.e. rate is proportional to 1 divided by time taken. The collision theory can be used to explain the effects of concentration and surface area on reaction rates in terms of the number of successful collisions. Temperature is a measure of the average kinetic energy of particles in a substance, and energy distribution diagrams can be used to explain how changes in temperature affect the kinetic energy. The activation energy is the minimum kinetic energy required by colliding particles before reaction can occur. The effect of temperature on reaction rate can be explained in terms of an increase in the number of particles with energy greater than the activation energy. With some chemical reactions, light can be used to increase the number of particles with energy greater than the activation energy. The reactant, which is present in excess in a chemical reaction, can be identified from the balanced chemical equation. This allows calculation of the quantity used up, and therefore the excess, after the reaction has completed. Experimental information in the form of tables and graphs can be used to solve problems concerning rates of reaction. Enthalpy. A potential energy diagram can be used to show the energy pathway for a reaction. The enthalpy change, which can be calculated from the potential energy diagram, is the energy difference between products and reactants. For exothermic reactions which release heat energy to the surroundings, the enthalpy change has a negative value. For endothermic reactions which absorb heat energy from the surroundings, the enthalpy change has a positive value. The enthalpy of combustion is the energy change when 1 mole of a substance is completely burned in oxygen. The units are kilojoules per mole. The enthalpy of solution is the energy change when 1 mole of a substance dissolves in water. The units are kilojoules per mole. The enthalpy of neutralization of an acid is the energy change when the acid is neutralized by an alkali to produce 1 mole of water. The units are kilojoules per mole. Laboratory methods for determining the enthalpy of combustion, enthalpy of solution, and enthalpy of neutralization are described. These methods use the equation energy transferred is equal to Cm delta T. The activated complex is an unstable arrangement of atoms formed at the maximum of the potential energy barrier during a reaction. The activation energy is the energy required by colliding molecules to form an activated complex. The activation energy can be calculated from potential energy diagrams. Catalysts. Catalysts are substances which speed up chemical reactions without being used up in the process. They are widely used in industrial processes. They can be classified as heterogeneous catalysts, homogeneous catalysts, or enzymes. Homogeneous catalysts are in the same state as the reactants, whereas heterogeneous catalysts, usually solid, are in a different state from the reactants. Heterogeneous catalysts work by the adsorption of reactant molecules onto the surface of the catalyst, with consequent weakening of the bonds in the reactant molecules. The surface activity of such a catalyst can be reduced by poisoning by substances containing elements such as sulfur and lead. Impurities in the reactants result in the industrial catalysts having to be regenerated or renewed. Catalytic converters are fitted to cars to catalyse the conversion of poisonous carbon monoxide and oxides of nitrogen to carbon dioxide and nitrogen. Cars with catalytic converters can only use lead-free petrol to prevent poisoning of the catalyst. Enzymes catalyse the chemical reactions which take place in the living cells of plants and animals. They are also widely used in industrial processes. Catalysts work by providing an alternative pathway for the reaction, which has a lower activation energy. Potential energy diagrams can be drawn to show the effect of a catalyst on the activation energy. Patterns in the periodic table. The modern periodic table is based on the work of Mendeleev, who arranged the known elements in order of increasing atomic masses in conjunction with similar chemical properties, leaving gaps for elements yet to be discovered. The modern periodic table lists the elements in order of atomic number and takes into account the electron arrangements of the atoms of the elements. Properties such as density, melting point and boiling point display a periodic variation across a period and down a group. Atomic size, normally quoted as covalent radius, decreases across a period from left to right and increases down a group. The covalent radius decreases across a period because the increase in nuclear charge attracts the electrons more strongly. The covalent radius increases on going down a group as the number of occupied electron shells increases. The first ionization energy is the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms. The second and subsequent ionization energies refer to the energies required to remove further moles of electrons. The trends in the first ionization energy across periods and down groups can be explained in terms of the atomic size, nuclear charge, and the screening effect due to inner shell electrons. Atoms of different elements have different attractions for bonding electrons. Electronegativity is a measure of the attraction an atom involved in a bond has for the bonded electrons. Electronegativity values increase on going across a period from left to right and decrease on going down a group.